Hey guys, on this video we're going to learn about axis of symmetry, vertex, and how to use those along with other things that we've learned to graph a quadratic function. And we're going to get into transformation later. So about graphing, let's look at this before we get too deep into it. Let's kind of go over our vocabs. So you see that highest point right there? Either the highest point or either your minimum or maximum. Either one of those, the highest point or the lowest point. That point right there is called vertex. Highest or lowest point of your quadratic function graph. Now, remember how we talked about this u? We could fold it in half and it would be proportional. Basically, the distance from here to here and here to here would be equivalent. Now, that line right there that folds this graph in half always and always and always will go through the vertex. And that special line right there is called axis of symmetry. I know that's not the best handwriting ever, but you know what I'm trying to say. And in class, I'm probably going to go ahead and abbreviate it to AOS, just because I am that lazy. Now let's use those information to kind of graph what we're going to graph. This function you've already seen before, but I'm going to reuse it to kind of get us to the point where we can graph this. First things first, we're going to find the axis of symmetry. That was that little line. That was a special line that we're going to try to look for. And the formula for this would be x is equal to, and because the line x is always going to be going up and down vertically, that's why we're going to have the equation set equal to x. So x is equal to negative b over 2a. And you are probably thinking, I've seen that before. This right here is from the quadratic formula, negative b plus over 2a. It's just the front part of it, negative b over 2a. That's going to give you the axis of symmetry. So let's go ahead and find our axis of symmetry. You know that's my a. My a would be the 1, b would be that. So let's plug it in, negative b over 2a, which will give you negative 2. Now that line right there would be, so we basically have x is equal to negative 2. Negative 2. So let's graph that line. I'm going to go to my negative 2. And I'm going to try my best to graph the straightest dotted line that I can possibly graph, which is not so straight. But here it is. I'm going to draw it as a dotted line because it really doesn't exist in that graph. We don't ever see that line going through when we graph the quadratic function. So it's just there for me to see. Now, the vertex, as I've mentioned, is always going to be on your axis of symmetry. So let's find the vertex. And here's what it is. We already know the x-coordinate of your vertex. So your x-coordinate of the vertex is always coming from your axis of symmetry. Now, we're going to find the y-coordinate. Needless to say, in order for you to do that, we've got to use our original function and plug in the x's to find your y. Remember, f of x is just the same thing as y is equal to. So let's change y is equal to x squared plus 4x minus 3. Let's see if I can kind of move this up. Then I would have y is equal to negative 2 squared plus 4 times negative 2 minus 3. And you can plug this into the calculator. It'll do it for you. But I'm just going to work it out with you guys. So I'll end up getting what? Negative 4 minus 3, which will be equal to negative 7. And I probably don't even have room for that. Okay, so I'm going to end up having to stretch. So that's my vertex, which means my line will have to be a little bit longer than it was. Whoop. It's like 1, 2, 3, 4, 5, 6, 7. So there's your 7. So that's going to be my vertex. So I'm saying my vertex right there would be on negative 2, negative 7. That's a beautiful dot that you see. And that's exactly where it's going to be. And that means your parabola is going to be stretching upward some way, somehow. Now, I already know where it's going to go through on my y-axis. So I guess I got to write you a note right here. So now, since you find your axis of symmetry and your vertex, the next step I'm going to do is to find y-axis. And I'm just going to help us out by erasing some of this right here. Okay, now let's find our y-intercept. That's what exactly what I mean, y-intercept, not y-axis. In order for us to find y-intercept, and this will kind of give us a really accurate graph rather than using some points, which I could. So y-intercept, remember, was the very last digit, -3. I know it's going to be a -3. So let's find -3 right here. Oh yeah, there's a little buddy. Now remember, it was proportional. So since it's 2 away from that line, right, it's 2 away from our axis of symmetry, there should be another dot right here, 2 away from that point. Now this is getting beautiful. Now once we get here, we're going to use another thing that we've learned in the past, which is called factoring, and see if we can factor to find my x-intercepts. So first things first, since I don't like quadratic formula, I'm going to try to see if we can factor. First times the last is equal to -3. Oops. Mid number is 4. -1 times 3 doesn't work. So I don't think this one's going to work out nicely for us. I don't believe so. So let's go ahead and use a quadratic formula for this. So -b plus or minus square root b squared minus 4ac, that's definitely 3, all over 2a. And you know that's going to give me two of my x's. So x is equal to what? -4 plus or minus 16 plus 12. Oops, what's happening? Over 2. I'm running out of room, so -4 plus or minus square root of 28 over 2. Now, I'm going to go ahead and use my calculator to find my 2 points as I usually would, right? So first one would be -4 plus square root of 28 all over 2. And this gives me 0.6. I'm just going to leave it there. And the second one would be -4 minus square root of 28 all over 2, which will give you -4.6. So those two are my x-intercepts. So kind of remembering that, -6 and -4.6. So I'm gonna try to graph that right here. 0.6 looks like right there to me, close to 1, and -4.6. So -4.6 is kind of right there for me. And you see how I got about 5 different points? You won't always get 5, but we're kind of lucked out. So since it did have x-intercept for us, it kind of makes us a beautiful quadratic function, even though it doesn't look that beautiful. So here it is. I use 4 simple facts. X-intercept, first of all, axis of symmetry, vertex, then I found my y-intercept, because you will always have those 3. And then number 4, if I have an x-intercept, I found it and used those to kind of sketch almost accurate graph of your quadratic function, even though it's not as pretty as you would like for it to. I hope this helped, and on the next video we're going to look for transformations, okay?